Hi everyone, this is Hardik from fuzzing.in. Thank you for watching my videos. In today's video, we are going to cover a very recent issue which was recently discovered and it has created a lot of media hype. So this issue is a backdoor inside a very popular compression library that is called HC. And in this video, we are going to see what this issue is, how it was discovered, and how can we replicate this issue, how can we set up the environment on our system, and how can we generate a pcap for that. So let's start. First, let us see how this issue was discovered. As you can see, there's an email from Andres who worked for Microsoft, and he sent an email on 29th March, that is a Friday, to this mailing list, that is OSS security and at the rate openworld.com. And what he has mentioned is that he was trying to troubleshoot some issues with the SSH, where basically what he found is that logins with SSH were taking a lot of CPU cycles, and he was also seeing some valgrind error. So when he was trying to troubleshoot like why this is happening, then he figured out that the actual exe repository has been backdoored, and then he sent his initial analysis on this mailing list. And he also mentioned that initially he thought that it is a issue with the Debian's package, but then what he figured out that it is a issue with the upstream, and then he sent his analysis over here. So uh, you can see that what he mentioned over here is that one portion of the backdoor is in the distributor tarball. He has also given a link. This link is actually not live now, it has been removed. So he has mentioned that this particular line is not in the upstream source, or it is not in the build to host which is used by exe in the zip repo. So it is not present over there, but it is actually present in the tarballs which are released on the upstream. Over here he has mentioned that there is actually a obfuscated script which gets executed at the end of configure. What he has also found is that there are actually two test files which were added to the exe test corpus, and these are the file which gets decrypted. They are actually obfuscated file, and these get decrypted, and that actually results in the backdoor. So the file names are given over here as well, and the first file is bat -3 corpus underscore lzma2.exe, and the second file is also given over here, which is named as good large compress.lzma over here. So there are a lot of bash scripting involved in this file to get decoded, and when you actually decode this file, uh, the first iteration comes across this. The first deobfuscation comes to this. You can see there are a lot of head and other calls. So basically what it means is that it is taking like 1024 bytes of data. Here it is taking 2048 bytes of data, and like that it creates another script which actually he has attached with this email. We will go through this script later on. What he mentioned is that this two file, right, contains a obfuscated backdoor code. They were actually committed to the git repo, and they were present inside test directory. So this is where all the test files were present. He also mentioned that this uh, code which were injected caused a lot of valgrind error and crashes. So this we are not supposed to work on each and every CPU architecture, so that's why it was causing some crash. And he has also done some analysis where he has mentioned that the obfuscated script gets invoked after the configure, and after that it has various checks, like it is targeting only x86 64-bit architecture on Linux, and then is also checking for the GCC compiler, as you can see it over here. And another interesting thing is that it is also checking if it's a Debian or if it's an RPM package build. So if it is there, then it will like compromise that. And he has also given time when it was not backdoored. You can see that it was like taking something like 0.299 seconds, but after the backdoor got installed, it was taking somewhere around 0.807 seconds. So another interesting thing he mentioned is that OpenSSH does not directly uses this particular lib, that is liblzma, but there are Debian and other distributors. What they do is that they will patch OpenSSH so that it supports systemd notifications, and for that they require liblzma. So this is how if you are using SSH on like Debian or any other repo which are using systemd service, and if they have patched it, then this backdoor can affect your system. And there are few more conditions as well, like term environment variable should not be set, then argv needs to be user has been sshd. So if your sshd is located inside some other directory like user bin sshd, then it will not work. And then there is also ld debug and ld profile should not be set, then language needs to be set. And uh, it also has checks for some debugging environment, like there is rr debugger or there is plain GDB, so it has some checks. So if it figures out that you are running it in debugger, then it will not work. In the end, you can see that there are three files which he has mentioned. One is injected.txt, second one is this actual backdoor, which is like generated after decoding and compiling, and the third one is a detect.sh script. So basically what the script does is that it will check for the function signature. So now let us go ahead and actually see this files, what does it contains, and then we will move to see how can we replicate this environment. So this is the file which has been provided with the email over here. This is like injected.txt file, and this seems to be a second stage file. So there are a lot of encoding decoding goes before this file gets generated. We are directly coming to this file, and you can see that this is actually setting up few configure parameter over here, like dash fpic, that is position independent code over here. And there are few variable which are being set over here. Then there are variable like get underscore cpu id, and then you can notice that these two are the malicious file which are being used over here. And if we search for this file, how these are getting used, so let's do $p, and you can see that uh, later inside the script this files are being used here, like this is the p and this is the u, and it is checking if this file actually exists or not. And then it is doing some other commands, it is running some other commands. So this is like a plain like shell file. And you can also see that it is like using a lot of scd commands over here. And then you can also see that after the file has been generated, it is copying it, it is actually copying it to the libs directory and all. It is modifying some make file over here as well. And it is making some changes to the make file. And if you go to the second script, which is like a detects assets, so this has been created just to check if your installation is vulnerable to this backdoor or not. So you can see it's a simple shell script, and what it is doing is that it is basically using ldd command to see what all are the libraries which are being used, and then it is doing a graph for liblzma. And if it is not found, then obviously it is not vulnerable, but if it founds, then it checks for the function signature, denotes that the file has been backdoored. So if it founds, then your environment is vulnerable. Now another interesting thing you will notice is that if we go to the GitHub repo, so basically GitHub repo has been removed, but the author or the maintainer of this project, he has one website where he is hosting all this code. So we can actually go through the commit, and you can see that the username over here, that is gr10, uh, who people claims to be have done all this thing. We can go ahead and see his commits over here, and we can identify that he has updated this to test file over here. So that is done on the 9th of March. And if we go ahead and see, we can notice that these two test files like bat-3 corrupt and good large corpus, he has made some changes to this file. Actually these files were committed before that. If you see that these files were actually committed on Friday 23rd Feb, and after that he made some changes on 9th of March in these two files. So we can actually go through his commits. You can, if you want, you can go to this particular URL and you can check all his commits. So you can actually go and see that he is part of this project since a very long time. I think like 2 or 3 years. We can see commits going to 2023 and 22 as well. So this is the commit I can see, 10th June 2022. So he has also done couple of changes, and we can also see that he has updated this git ignore over here. And if we see the diff over here, You can see that he has added this build to host.m4 file over here, which is related to the backdoor over here. So this activity was done on 15th of February 2024. So anyway, if we want to replicate this issue at our end, then what you can do is that there are two repo. The first one is hosted on this particular URL, that is github.com 0xlane slash xcv2024-3094, and this repo has given step-by-step instruction on how you can actually like decode these files. He has also given the actual this tar file hosted over here, and he also has one Yara rule which you can use to check, and the two file which were encrypted has been decoded and kept in this repo as well. So if we see at bat3 corrupt, you can see that it contains after decoding you can see something like this, right? So these are the content of this file, and if we check the second file, that is good large compress lzma, then you can see that this contains the uh, like shell script as we have seen over here. So these are the decoded files, and he has also given you the steps which you can use to compile this file, and he has also given the compiled file over here. So if you want to see what is the difference, what changes has been made to like makefile, you can simply go and check makefile dot diff, and you can figure out all this difference, like this file has been added over here, then the directory for this file has been added over here, then these are the changes which are added to the uh, makefile, and this r path is points to the that directly containing the malicious test files, and there are other changes which you can see. So you can actually see the difference, what changes have been made to makefile, and you can also see what are the changes has been made to this crc32 underscore fast.c file. So you can see that few lines has been added over here, and if you go and see other crc fast 64-bit, you can also see that a few lines has been added over here as well. You can also see there are some changes in the lib tool. So yeah, few flags has been added over here, and this is the Yara tool. So what it does is that it simply checks for the function signature, and yeah, this is the same as we have seen in this particular script. So that is fine. Now what we are going to do is that we can see how we can configure this particular environment and how can we generate the pcap, and if we can replicate this issue at our end or not. So for that we are going to use another repository that is called xzboard. So let us go ahead and see how we can set this up on our system, and for this what I am doing is that I am using a Ubuntu based system, and I have actually already cloned this in my system. But if you want to clone this, you can simply run this command, that is git clone https github.com aml pims xzboard.git, and it will actually clone this repo on your system. So if we go inside this repo, we can see that there are a couple of files which are written in Go, and we can see that there is one directory named assets over here. So if we go inside assets directory, we can see that there is a liblzma version 5.6.0, and there is liblzma 5.6.1 present inside this, and it has been patched. So there are patch file available as well. Now what this patch file means is that by default this backdoor uses a standard now why this there are two patch file is this is because to change the key inside uh, this particular backdoor uh, now why you're seeing two patch file over here, this is because to change the key which is being used by the backdoor, as we don't know the key you private key used by the backdoor, we cannot do anything. So there is a patch, and if you apply this patch, basically it will change that key, and you can easily decrypt the data, and you can actually see what data is being sent. There are two options. If you have this installed on your system, then you can patch it, or you can directly use this patch file. So you need OpenSSH server installed on your system, and if you don't have, then you need to run this command, that is sudo apt install OpenSSH server. So when you run this command, it will install OpenSSH on your system, and you can also see the status for SSHD. So you can see that on my system, this service is running, and let us figure out what is the path for liblzma on this system. So first thing we need to see is where our SSHD is present. So we can see that our SSHD is present inside user slash admin. So now we will use ldd command, and we will see what all library it is using. So we can see the output, and we can see that it is using liblzma, and this file is present inside this directory over here. So let me actually clear the screen so that it's more visible to you. Now we can run this command, that is file, and figure out if this is a symlink or this is an actual file. So we can see that it is actually a symbolic link to liblzma.so.5.2.5.back. So what we can do over here is that we can simply remove this file, and we can copy the file which is present inside our sales directory. So this is the patch file, right? And we can use this file. So what we need to do is that we need to copy this file, patch file, as liblzma.so.5.2.5 over here. So if we copy this file, so this is the backdoor file with the key change. So this contains the key which this particular author has mentioned over here. So this is the actual attacker's key, which is being replaced by our own key, so that you can actually decode the data. And now what we can do is that if we run SSHD service on our system, it will use this backdoor version, and then we can actually communicate with that using execboot. So now let us start systemctl status SSHD. So basically we will stop it first so that the service gets stopped, and then we will start it again. So we will use this command, that is systemctl start SSHD, and now we can actually check the status if it is working or not. So we can see that okay, it is working and it is listening on port 22. Now to use execboot, we need to build this uh, build binary for this. So you can see that there are a couple of go files. So what you can do is that you can simply type go build, and when you do that, you can see that a new file named execboot has been created over here. So if we do execboot, and let's see help first, so you can see that it expects address, and you can also give any command, and you can also give some seed over here, which is by default set to 0. So we will be first use like so we'll first use address command, and let's see what happens. So let's type execboot address, and let's see localhost, and port is 22. So you can see that our connection is happening. So this execboot is able to communicate to the SSH server running on our system. Now let us try with some command. So we will use .exe /execboot address, and let's use command as touch, and then dash time directory pound. So what this command will do is that it will create a file inside time folder with the name pound or owned. So let's see if it runs. So we have actually we are able to see this output from the SSH, but we are not sure the file is created or not. So what we can do is that we can ls dash time, and we can see that this file is created. Now let me do one more thing. I will remove this file so that we can verify that it is working or not. Okay, so I have removed this file, and if I do ls again, you can see that this file is not present here. Right now we will again run this execboot command and see if this file has been created or not. So I will simply use this command, that is .execboot address, which is of our local system, port is 22, and then the command we are giving you over here is touch and the space slash temp slash pond. So what this command will do is that it will create a file name pond inside temp directory. So let's see if this is getting executed or not. We will simply do ls temp, and we can see that this file is getting created over here. So this is how you can actually replicate this issue at your end. And now let us see how can we generate pcap for that. So generating pcap is straightforward. We simply need to use tcp dump. So let me run command. You can run sudo tcp dump -i localhost right and xg backdoor.pcap. So this is the file name, and let's start tcp dump on our system. And now let's actually run this command. Let's give it pond2 over here, and we can see if it is executed successfully or not. So we can see that this file has been created over here, right? And now we can stop the capture, and we can see that 44 packets were received, 22 packets were captured. So let's open Wireshark and see what kind of traffic we see with this. So you can see that we are able to see the SSH traffic over here. This is the planned SSH protocol, and then there is a server, then there is key exchange INIT or key exchange initialization. So you can see all this like data over here, and you can also see server key exchange initialization message over here, and there are new keys. So since SSH is encrypted, you will not be able to see the command over here, but this is how the network capture looks like for this particular backdoor. So if you are interested in knowing more about how to deobfuscate this script or what these scripts are doing, then the Gyanvel, GYNVAEL, I'm not sure if I'm pronouncing it correct or not, but he has written a great article over here, and he has given details on different stages like stage 0, what it does, then there is stage 1, and then there is stage 2 as well. So I will recommend you to go ahead and read this particular article. There are also few people who have work on this, and they have given detailed analysis. So one of them is posted on the page pin. I'm not sure who is the author for this, and there are few links as well which you can go through. There is one link which is hosted on which is actually gist and hosted on this account. That is the same Sam, and he has given some fact that is frequently asked questions, and he has given some details like what is payload and all those things. And then there are some detailed there are some links over here as well. So one of this link I found over here, this is this one actually, and then there are some other link as well, so you can go and read more about that. But I hope that this video has given you an idea of what this backdoor is and how does it work. So I hope that this video has given you a general overview and idea of what this backdoor is, what it does, and how can you create the environment and how can you capture the PCAP for this. Please feel free to subscribe, like, and share my channel. That will motivate me to create more such videos. Till the next video, stay safe, enjoy, goodbye, thank you.